Hello students, in this lecture I am going to discuss about real-time operating system based embedded system design. So let me discuss what is operating system. So operating system, as you can see, it acts as a bridge between the user application and the underlying system resources, or you can say hardware. So this operating system manages the system resources and makes them available to the user application or task on a need basis. So this the basic components of operating system consist of this kernel. There is a kernel. So the kernel is the core of the operating system and is responsible for managing the system resources and the communication among the hardware and other system services. The kernel, this kernel contains different services for handling the following, like process management, then time management, memory management, file system management, and input output system management. So process management, it includes setting up the memory space for the process, that or loading the process code into the memory space, allocating system resources, scheduling and managing the execution of the process, etc. File system management service of kernel is responsible for creation and deletion and alteration of files, creation, deletion and alteration of directories, saving of files in the secondary storage memory, providing automatic allocation of file space based on the amount of free space available, etc. Input output device management, in this the kernel is responsible for routing the input output requests coming from different user applications to the appropriate input output device of the system. So the now next is the memory management. We'll talk about secondary storage management. The secondary storage management service of kernel, it deals with disk storage allocation, disk scheduling, free disk space management, etc. Then we have protection systems. Like most of the modern operating systems are designed in such a way to support multiple users with different levels of access permissions. Example, Windows XP. So in multi-user supported operating system, one user may not be allowed to view or modify the whole or portions of another user's data or profile details. Then we have interrupt handler. This kernel provides handler mechanism for all external or internal interrupts generated by the system. So this was about the operating system architecture. Now we'll see the applications or services. They are classified into two categories, that is user applications and kernel applications. And the program code corresponding to the kernel application or services are kept in a contiguous area of primary memory and is protected from unauthorized access by user program or applications. So the memory space at which kernel code is located is known as kernel space, and similarly all user applications are loaded to a specific area of primary memory, and this memory area is referred as user space. Then we have then we have this kernel classified into monolithic kernel and micro kernel. So in monolithic kernel architecture, all kernel services, as you can see, in monolithic kernel architecture, all kernel services run in the kernel space. The major drawback of monolithic kernel is that any error or failure that is occurring in any one of the kernel modules will lead to crashing of the entire kernel application. So this is the example of monolithic kernel. Then microkernel, as you can see, the microkernel design incorporates only the essential set of operating system services into the kernel. The rest of the operating system services are implemented in programs known as servers, which runs in user space. So microkernel based design approach offers the benefits like robustness and configurability, etc. Now moving on to the types of operating systems, the operating systems are classified into this general purpose operating system and real time operating system. So the operating system which are used in general computing systems, they are referred as general purpose operating system, and the kernel of such an operating system is more generalized and it contains all kinds of services required for executing generic applications, for example Windows XP. Then we have this real-time operating system. This real-time implies deterministic timing behavior, and it means the OS services, that is operating system services, consume only known and expected amounts of time regardless the number of services. This real-time operating system decides which application should run in which order and how much time needs to be allocated for each application. Then we have this real-time kernel, that is the kernel of this real-time operating system is referred to as real-time kernel, and the basic functions of real-time kernel are this task or process management, task or process scheduling, task or process synchronization, error or exception handling, memory management, interrupt handling, and timing management. So this task or process management, it deals with setting up the memory space for the task, loading the task code into memory space, allocating system resources, setting up a task control block for the task. A task control block, it is used for holding the information corresponding to a task, and this task control block contains the information like task ID, task state, task type, task priority, task context pointer, task memory pointer, task system resource pointer, task pointer, etc. Then task process or scheduling, it deals with sharing the CPU among various tasks or processes. Then task process synchronization, deals with synchronizing the concurrent area of a resource which is shared across multiple tasks and communication between various tasks. Then we have error or exception handling. It deals with registering and handling the errors occurred or exceptions raised during the execution of tasks. Insufficient memory, the examples of this error or exceptions are insufficient memory, timeouts, deadlocks, deadline missing, etc. Then we have this memory management. In memory management, the real-time operating system makes use of block-based memory allocation.